Logarithmic equations, question 34. Solve log 3 of 3 minus x plus log 3 of 4 minus x minus 2 log 3 of 2 equals to 1. So first we can combine all these terms on the left hand side because all have the same base, right? So let me rewrite this equation and then we'll combine it. So it is log 3 of 3 minus x plus log 3 of 4 minus x minus log 3 of 2 square, right? So 2 square is 4, so we'll write 2 square is 4 equals to 1. Now this could be written as log 3 of 3 minus x times 4 minus x divided by 4 equals to 1. So that means 3 to the power of 1 is equal to this number, which is, this expression is 3 minus x times 4 minus x over 4 is equals to 3 to the power of 1. Now we can cross multiply and then get 3 minus x times 4 minus x is equals to 12. Now let's solve this equation. So 3 times 4 is 12 and 3 minus x gives us minus 3x, minus x gives us minus 4x, and minus x is minus x squared equals to 12. Now we can bring all the terms to one side and we have x squared and minus becomes 7 minus, which is plus 7x when we take it on the other side, and 12 and 12 is 0, so this is equal to 0. So we can factor this out. We set x common and we get x plus 7 equals to 0. And so we have two solutions here. One is x equals to 0 and the other one is x equals to minus 7. So these are our solutions. Now mind it, when we have this expression here, we need to check our domain, and the domain is that this number 3, this x has to be less than 3, right? So one is that x is less than 3 for that to be true, otherwise this will be negative. And here x is less than 4, correct? Okay, x is less than 4 for this to be true, right? So basically x is less than 3 is our restriction on this function, correct? So these two are valid answers. The other way we can do is we can check this one, because this should always be positive. So that you can graph and check. Well, the results are here, but I'm just showing you an alternative way of doing it. So this gives me a root at x equals to 3. Let us say x equals to 3 is here, and the other one at 4. Let's say this is 4 here, right? Now, when you actually take minus common both sides, so it becomes basically positive, right? So you have an equation which is so if I take minus for this, it becomes x minus 3, and minus for this, it becomes x minus 4, so x is positive. So we get a function like this. So we know that it is positive if it is less than 3. So that is what less than 3 is, right? So net result is that we have to be less than 3 for all the three situations. And as we see, both of them are less than 3. So both are valid solutions, right? If I plug in 0 here, all are positive. If I plug in minus 7 here, even then both are positive, right? So both work, right? So we can just check them by placing the values. If I put 0 here, then let me just write down here So we'll just check with both the values. If I plug 0 here, then I get log 3 of 3, which is 1. And here I'll get log 3 of 4. Okay, so to check this answer, what we are going to do is we are going to plug this in our equation, right? So if I put 0 here for x, then we get 4 times 3 is 12, and 12 divided by 4 is 3, and log 3 of 3 is 1, so that's correct. If I put minus 7 here, then minus 7 will result into 3 plus 7 gives us 10, and 10, and this is 4 minus 7, so let's put 7 here. So we get log of 3. If I put minus 7 here, then I get 10 times minus 7, 10 times 11 divided by 4. And that is not resulting into 1, and therefore minus 7 is not the right answer. So that does not really give us, so not a solution. Right, so the only solution is x equals to 0, right? So we have a solution here which is x equals to 0. So whenever you are solving with these equations, you should always check your answer and then figure out if that is working or not. So the solution for our equation is x equals to 0.